So the objective this week is to give you a brief overview of water PVT. And when it comes to water, there's two things in particular that can be important. It's, what is the water viscosity and what's the water density? And that's a function of temperature and salinity primarily, and that's what we're going to go through today. Typically, we don't discuss water PVT that much because water PVT isn't as complicated as, for instance, oil and gas, but in some instances, it can actually be really important. A very good example for unconventionals would be for a pipe flow type of calculation, where if you're off on your water density, then that can actually shift your bottom pressure calculations quite a lot, actually, if you haven't accounted for the water specific gravity or density, if you like. So very quick on water, kind of the one pager on water is that water viscosity ranges typically from 0.3 to 1 centipoise at ambient temperatures. So that's kind of the range, order of magnitude. Good to know. The water compressibility is typically 2.5 to 5 in general, so it's not very it's not very compressible, which is one of the signatures, if you like, of water. The reservoir brines themselves, when they have been in the reservoir and they go to surface, the shrinkage is very little. It's typically much less than 5% when produced to surface. So in many cases, folks actually ignore that little shrinkage to surface. The brine will always share pore space with other types of hydrocarbons, so they can contain a little bit amount of gas in solution. So for instance, if you're dealing with a field that has a ton of mobile water and it's a very gassy field, actually accounting for this can be important in those edge cases. For typical Whitson Plus use, however, would be primarily to know how you would change your water salinity and how that water salinity impacts the calculated density and viscosity. So that's what we're going to do today. There's multiple places inside of Whitson Plus where you can change this. In the numerical model, for instance, it will be under here on the fluid initialization. And I'm going to zoom in a little bit so it becomes a little bit clearer for everyone. Important here, water salinity is typically between 0 and 300,000 parts per million. So when I change this and I increase it going higher, you'll see that the density and viscosity is increasing compared to fresh water. Okay, so this is fresh water, and if I make it, let's say 100,000, it goes up a little bit. Okay, it goes up from fresh water to whatever this is. So this would be around 0.6 specific gravity or something like this. From 100,000 up to 300,000, it is a pretty steep function. So if I change this number here to 200,000, for instance, you see the density changes a lot. And if I took it up and actually made it 300,000, you can see that the density is almost changed with 25%, and viscosity has essentially doubled. So we'll have a big impact there. And that's just for you to build your intuition about the ranges and when it's really important. I'd say from 0 to 100,000 parts per million, it's not as important, but it will be very, very important when you go above there. So that, what's important or not is also a function of what you consider to be accurate. In all the other features, in numerical RTA, for instance, you can access it over here. And of course, if you go into a particular well, salinity can be inputted as well over here. And of course, if you want to edit a lot of wells at the same time, the water salinity will also be possible to input here in bulk mode under the attributes. So again, if you are on the well level here, for instance, and you want to change the attributes, they'll be up here to the right.